In this video, we're going to continue multiplying polynomials. This is part 3 of a 3-part video. In the first video, we looked at multiplying 2-digit numbers. The second video, we looked at multiplying 2 binomials, which are polynomials with 2 terms. Now, we have a trinomial times a binomial, and so this is a more advanced polynomial multiplication problem. And again, we're going to go through the same 3 methods that we've worked on before in the previous videos, linking your previous multiplication knowledge from earlier in your math career to the polynomial multiplication. Method 1 was more of a traditional multiplication method, where we stack vertically 5x squared minus 4x plus 3, and then using like term columns, the -7 and the x to the first from the second polynomial is going to go right here in line, and we'll multiply. -7 times 3 is -21. -7 times 4x, positive 28x. Notice my answers. This was a constant in the constant column. This was x to the first, or linear term, that goes in the linear column. -7 times 5x squared is going to be -35x squared, which will go in the quadratic column. Then in traditional multiplication, we would usually have a placeholder here that we would just put a 0 and then move on because we're in the tens place. Well, now I'm multiplying a linear term, x. So if I just pay attention to what the answer is and make sure that I keep them in the appropriate columns by like terms, the placeholder isn't necessary, but we might put it in if there is one. X times 3 is positive 3x, which will need to go in the linear column. So you could still write plus 0 if you want. That is, again, not necessary, but that might be helpful for you. Then x times -4x is going to be -4x squared. Make sure to put that in the quadratic column. X times 5x squared is going to be 5x cubed. Well, I don't have a cubic column, so I need to add that in. Keep making sure that my like terms are all organized in columns. And if you remember our addition, polynomial addition, we stacked that up again just in like terms, getting ready for this. Now we'll just add the like terms. So we have 5x cubed minus 39x squared plus 31x minus 21. And here is our answer. Now, the second method was the area method, and that works for this as well. We just have a different shaped rectangle because we're going to have 3 boxes since there are 3 terms, 5x squared, -4x plus 3, so that polynomial has 3 terms. And then this dimension represented by the binomial x minus 7, 2 terms. We're going to multiply and find the little area of each of these little boxes. And so in the previous videos, I kind of talked about them as little products because we're just multiplying a component of this problem. This would be the final product, and all of those little multiplication answers or little products what we're talking about. These answers that we got here should be the same here in this method because we're multiplying the same problem. So the same terms are going to be multiplied by each other, just in a different order and organized differently. So 5x squared times x is 5x cubed. 5x squared times -7, -35x squared. -4x times x is -4x squared. -4x times -7 is positive 28x. positive 3 times x is 3x, and positive 3 times negative 7 is negative 21. You see 5x cubed minus 4x squared plus 3x. Here was that product. Negative 35x squared plus 28x minus 21. That was our second row here. So all of the little products are the same, but you see here they were organized in like term columns. Here the like terms often in this method will show up diagonally. But we still have to combine the like terms, just like in the first method. And we should end up with the same answer since it's the same problem. And we do. And the last method we looked at was more distributive property focused and kind of the extended distributive property. Where we're distributing more than just a monomial. And here I'm going to actually distribute backwards, so the binomial into the trinomial. So x is going to be multiplied by 5x squared minus 4x plus 3, and the negative 7 is going to be distributed into the 5x squared minus 4x plus 3. And when I distribute, I get 5x cubed minus 4x squared plus 3x. Again, those little products are found in each of the other problems because, again, we're multiplying the same numbers, just organizing differently. Students, I have found, have made mistakes in this method at this point, the combining like terms part. One of the areas where people will make a mistake is they forget that the positive and negative sign is a part of the term. So this is negative 35x squared. So when combining that with the negative 4x squared, they might say positive 35x squared accidentally. Or you might combine not like terms. You might lump this 3x to the first in with the negative 4x squared accidentally. So you got to be very careful. For me, I sometimes, if I'm using this method, will combine the like terms this way to kind of indicate where my answer should go. 5x cubed, the square terms together, negative 39 x squared. Now the linear terms together, positive 31x, and finally the constant that remains. And you see this is the same answer. But it's possible that you combine method 1 with method 3. That might be an even better approach for you, where as you distribute, you just set up your addition problem. Instead of in a row like this, you set it up in columns by like terms. So from this step, you could come down and say, okay, I distribute the x. That would be 5x cubed minus 4x squared plus 3x. Now when I distribute the negative 7, I have negative 35x squared, and I would just write it in the x squared column like we've talked about here. And then the negative 7 by 4, the positive 28x, let me put that here in that column. And negative 7 times 3 is negative 21, which would be in the constant column. So then I would add this way. And, they're lined up by like terms, and so your answer would still be the same. This is how you might combine the distributive property sort of method with this vertical addition from the traditional method. Again, I have no preference for which method you use, but I prefer for myself method 1 or the combo of 3 and 1, where I'd set it up this way, but when I get to do the multiply, I would set my addition up vertically. Again, do what's most comfortable for you. I wanted to make sure that we tied your previous multiplication knowledge to the polynomial multiplication, where you could see that it's exactly the same in process, and that's going to help you also moving forward as you continue your mathematical journey.